Hi, my name is Giovani Ângelo Silva da Nóbrega, and this video is part of final evaluation of Advanced Data Science Capstone. The title of my presentation is Automatic Diagnosis of Pigmented Skin Lesions Based on Images. The World Health Organization has reported that non-communicable diseases have become to concept due to endemic growth, and in the list of the diseases, skin cancer is present. Data understanding. The database used in the experiments contains 10,015 images with the following types pigmented lesions. The database was offered by Harvard Dataverses. Data understanding, data exploration. The dataset contains age, gender, localization of the lesion, type of cell, and images of the exam by patients. Here had three charts that explore the attributes to age, localization of lesion, and gender of patients, and we can see this data is balanced. After the on class is a few, but it's not problem because the not concentrated in only value. And data adjustment, data balancing by classes, and the data had 7 classes, but they have few examples in vascular lesions and dermafibroma, and because this I removed 3 classes, remove actin, keratosis, vascular lesions, and dermafibroma, and use it only these 4 classes, but use it only for these classes 514 examples randomly chosen formate the dataset used. And the dataset have 57 examples with new value ages, and for to resolve this I made an imputation using the mean of the dataset. 2 models to generate the classifier used the multilayer perceptron and convolutional neural network. The multilayer perceptron is a classical algorithm of the machine learning and very used because this is a choice. The convolutional neural network is a deep learning algorithm that captures input images, assign important weight and bias that can be learned to various aspects, objectives of the image, and able different for each other. Because this convolutional network is choiced to these experiments. And particular characteristics of these 2 algorithms, MLP or multilayer perceptron, the input data is linear features, but the CNN convolutional network, the multilinear features. To data transformation, you need data transformation to use the images in MLP, because this using the hierarchic features or texture features. The hierarchic features used the gray level occurrent matrix is similar to histogram 2D, and generate this matrix, and after generate this matrix you calculate the contrast, the similarity, homogeneity, angular second moment energy, and correlation. After this, I use the PCA to remove the uncorrelated columns of the dataset. It's a technical very used to this because the transform the possibility correlated variables into a smaller number of variables called principal components. After this, I use a data transformation and use it to standard score. It's a simple calculated in the minus mean and divided to standard deviation of database. In the pipeline is the images, extract hierarchic factories, and union gender, localization of lesion, and age of patient. Normalize it using standard score, pass PCA, and after this, training MLP. And CNN is similar, but very more simple, and because the images is input to CNN, but I normalized the images by standard score. To analyze the results, I use the confusion matrix. Is a table composed by results widely used in the analysis of classification-based models. Each row is a matrix represents the expected instance the class, while each column the matrix represents the instance of the classes. This value is true positive and true negative is very important to analyze the confusion matrix. Rock curve is used to graphical representation the sensitivity pairs in order axis and specific abscisses in the abscissa axis, and the area above the chart is the accuracy of the tests. Now go to the code. I will show the models used and the results and the architecture of the models. In the first model, I will show the CNN, convolutional neural network, and this part of the code is normalization of the database, generation, the X-training, X-text, and validate sets. And now the architecture of the convolutional network used and is summarized here, and the convolutional layers, max pooling, convolutional layers, max pooling yet, and convolutional layers and max pooling yet. 3 steps, and flatten data output, densed, and densed yet, using ReLU activation function and the padding same technique of the adjust, and the model to compile optimization, the function Adam. Loss is regulated by binary cross entropy, is a good strategy, and metric to adjust is accuracy. And to training using 50 epochs and batch size is 100. The results of the convolutional network is very good. The value is true positive, is higher than others. And the rock curve is general rock curve. All accuracy is 80%, is a good accuracy. And by class, all classes used in database is 19, and minus is 83%. To model multilayer perceptron I need the rainbow structured descriptor of the images, and because this I use hierarchic factories and implement this function using RGB. images to extract algorithmic features RGB images, and remove null and nonce input using mean strategy. And now union all data to make the data to use this experiment with MLP. And normalization with standard scale or z-score, and using PCA to remove correlated columns, and use in MLP classifier is user function Adam to optimization, strategic learning rate is constant, and 40 neurons in hiding layer is only single hiding layer, but the MLP uses 30 epochs to adjust, and this confusion matrix show it, and the melanocity neve is very good accuracy, but the benign keratosis is not good and very confusion here, and the accuracy is not better than CNN, had 74%, and the per class is 2, the seventh, and the minimum is 66%, and the maximum is 88%. The conclusion, and the database offered the Harvard Dataverse is challenging widely to use, and they studied by research and programmers around the world. This fact is influenced by importance of developing key practical solution that helps diagnostic of disease. In the studies presented here, it was possible to conclude the strategy that using deep learning based classifiers are more likely to be more efficient than classic machine learning based algorithm for this problem especially. Another important thing is testing with other image descriptors as well, and other processing techniques. This can lead to greater efficiency of both models. My presentation. My special thanks of the Coursera, IBM, Harvard Dataverse, colleagues of course, and you. Thank you very much.